So we are working on finding the distance between two ordered pairs. I have one more example of this, example 4, and we're going to be finding the distance of example 4 by using the distance formula. I have the formula up there on the top right. I have given you your two ordered pairs of 3, -6, and -1, 4. And I encourage you to pause the video to see if you can come up with the most simplified answer as well as an approximate answer for this example. So the first thing I'm going to do is label my ordered pairs as x1, y1 and x2, y2. But again, if you label them in the opposite format, it would still work out to give you the same answer. My distance is the square root of my x2 value of -1 minus my x1 value of 3 squared plus my y2 value of 4 minus my y1 value of -6 squared. Don't lose your double negatives. That's one of the biggest mistakes that I see. Another mistake that I see here is people inputting the x and y values incorrectly. So an example of that is a student might put these numbers both in my parentheses here and these two numbers in my parentheses there. Note that you should never have the same two numbers in your ordered pair in your formula. You should always be comparing the x's and the y's. So now that I'm sure I've got everything entered in correctly, all I have to do is basic math, just simplification. First, -1 minus 3 gives me -4 squared. 4 minus a -6 is the same thing as 4 plus 6, or 10 squared. I must square these before I square root them. Another mistake that I see quite often is people canceling out the squares and the square roots. You cannot do that because there's addition and subtraction involved. PEMDAS says you must work the inside of your parentheses first. So I must simplify this parentheses here, and I must do square root as the very last step. So 4 squared gives me 16, plus 10 squared gives me 100, gives me the square root of 116. Now, to give the most simplified exact version of this, I need to break this down into a good and a bad pi. The largest square that goes evenly into this is 4, and 4 times 29 gives me 116. So the square root of 4 gives me 2, and then I'm left over with my square root of 29. So my exact answer of this is 2 times the square root of 29. We almost always want an approximate answer of this, so we can do this by plugging it into the calculator. 2 square roots of 29 or square root of 116. Either one of them will give you the same answer, and you can type both of them in to confirm your answer. So let me type in the first, square root of 116. And my simplified of 2 square root of 29. And both of them give me this answer here. So my approximate answer, rounded to 3 decimal places, is 10.770. So I have an exact and an approximate answer for this example 4. You can always kind of double check your answer by drawing it up on the rectangular coordinate system and seeing if your distance being somewhat close to this 10.770 is an appropriate solution to that. So I've given you quite a few examples of finding the distance between 2 points or 2 ordered pairs, and you actually have a choice as to what route you want to take, by drawing it up and using Pythagorean's theorem, or by memorizing and using the formula. Either way is your personal preference, and both of them will always give you the exact same answer.